So here we are going to demonstrate about dual axis solar tracking system. The major components of our project are servo motor, solar panel. There is an MG995 servo motor at the bottom end also. So this is a dual axis solar tracking system. So this will be working with the help of an ESP32 controller, where it is going to take the X and Y axis and going to give input to the servo motor, so that it will be rotating according to the angle of the location which we have written in the code. So the major components here are adapter, IOT LCD display, regulated power supply section, LM2596 buck converter, voltage sensor. And initially this is an solar panel. The output voltage will be given as an input to the voltage sensor, so that it will be reading the live voltage and showing on the LCD display. So initially this will be working with the help of an adapter, which is going to give 230 volts AC to 12 volts DC, and being given as an input to the LM2596 buck boost converter, at the same time to the regulated power supply section. From this regulated power supply section, we are going to give input voltage to the ESP32 voltage sensor, IOT LCD display, and whereas LM2596 is going to give n plus 5 volts to the servo motor, so that the motors will be rotating according to the angle of the value. So in the code we have given the location. So this is the username and password, the website from which we are going to take the azimuth and elevation angles, and this is the location on which this azimuth and elevation angle will be working. And the data can be seen in the serial monitor also. So before that, you have to turn on your mobile hotspot, and so this is the username and password, project123, and the password is 128, and the baud rate, AP band should be like 2.4 gigahertz. And after turning on the hotspot, you have to turn on the kit, and the device will be connected. So initially this is the initial position of the system, and it will be taking the direction of the latitude longitude values which we have given, and the data here will be showing the voltage of the solar panel from which it is being generated. So this is how the entire system will be working with according to the location, and live update will be happening according to the motion of the X and Y axis and the direction of the sunlight. So this helps to run the system without any kind of disturbance. So you can rotate whenever there is an cloudy conditions also, you can able to run the system. Thank you.